என்ன வேணும்? Dynamic programming. Dynamic programming is a general algorithm design technique for solving problems defined by or formulated as recurrences with overlapping substances. Here the main idea is set up a recurrence relation, a solution to a large instance to solutions of some smaller instances. Solve smaller instances once, record the solutions in a table. Extract solution to the initial instance from that table. Examples of dynamic programming algorithms. Computing a binomial coefficient, longest common subsequence, Warshall's algorithm for transitive closure, Floyd's algorithm for all pair shortest path, constructing an optimal binary search tree, then traveling salesman problem, knapsack problem. These are the types of problems can be solved using dynamic programming concepts. Warshall's algorithm. On the kth iteration, the algorithm determines for every pair of vertices I, j if a path exists from I and j with just vertices 1 to up to k allowed as an intermediate. The formula used here is R of k I, j equal to R of k minus 1 I, j or R of k minus 1 I k and R of k minus 1 of kj means path using just 1 to k minus 1. The next one is path from I to k and from k to j using 1 to k minus 1. Warshall's algorithm. Rules used here is if an element in row I and column j is 1 in R of k minus 1, it remains 1 in R of k. If an element in row I and column j is 0 in R of k minus 1, it has to be changed to 1 if and only if the element in its row I and column k and the element in its column j and row k are both 1 in R of k minus 1. So example for Warshall's algorithm. So input graph. The adjacency matrix representation of this graph is shown here. R of 0 here 1 to 1 no path, 1 to 2 no path, 1 to 3 there is a path, so here 1, 1 to 4 no path 0. Likewise we have to complete this matrix representation. Then take first column and first row. Here 1 0, so 0 1 1. Third row second column value 1 1, so here we have to put 1. See here 1. Then a 0 1, so already 1 is there, so we are putting 1. Next all are 0. This is R1. Now take the second column and second row. Second column and second row like this, how to fill the matrix. Then how to take third row, third column, then fourth row, fourth column. This is the final output. Warshall's algorithm. The input is the adjacency matrix representation of a given graph. Let R of 0 equal to adjacency matrix of the graph. For k equal to 1 to n, do. Then for I equal to 1 to n, do. Then for I equal to 1 to n, do. Here the k loop is used for each step, R of 1, R of 2, R of 3 like this. Then I and j is used to represent column value and row value. Then R of k of I comma 1 equal to, how to put the recurrence relation, R of k minus 1 I comma j, or R of k minus 1 I comma k and R of k minus 1 kj. If means if there is 1, keep the value as it is, otherwise check it in the previous step, the column value and row value. If both are 1, then the current value is 1. Floyd's algorithm. On the kth iteration, algorithm determines shortest path between every pair of vertices I comma j that use only vertices among 1 to k as intermediate. The recurrence relation for this is d of k I comma j equal to minimum of d of k minus 1 I comma j comma d of k minus 1 I comma k plus d of k minus 1 k comma j. Here this is a weighted algorithm, so we are choosing minimum of the current value and the previous steps row value and column values are added and compared with the current value. Minimum of that value is taken as the cost of current matrix. Floyd's algorithm. This is the given graph. The weight matrix is shown here. Here from 1 to 3, cost value 3. So here 3. 1 to 2 no path. So we are inserting infinite here. Likewise fill this matrix. Then let the first column and first row. Here in this position infinite, the corresponding column value 2, row value 3. So 3 plus 2, 5. Minimum of infinite comma 5, 5. So change as 5. Then here the value is infinite. Column value 6 and row value 3. 6 plus 3, 9. So change as 9. Likewise check for all the values, then let the second column and second row. Here in that position 7 plus 2, 9. So 9 is minimum, so change as 9. Here 7, 2, in this position 9, change 9. Likewise check for all values. Then take the third column and third row, do the same process. Then fourth column, fourth row, do the same process. The final output is D4. The algorithm. Here the Floyd algorithm takes weight matrix as input from k1 to n, j1 to n, i1 to n. K is used for steps, each steps. I and j is for column value and row value. Here we are taking minimum of current value and the column value plus row value. So d of ij comma d of ik plus d of kj.